Hi, I'm going to graph the parent exponential function of y equals 2 to the x. So right here where we have the graph y equals 2 to the x, what this represents is a base of 2. So we call that a growth factor of 2. Let's go ahead and input our values. We can see here what happens when x is -3. Well, 2 to the -3 we know is the same as 1 over 2 cubed, which is the same as 1 over 8. So at -3, y is 1/8. And if we go down the inputs, we have 2 to the -2, that is 1/4. 2 to the -1 is 1/2. 2 raised to the 0 is just 1. 2 to the 1 is 2. 2 squared is 4. And 2 cubed right here is going to be 8. So now that I have my ordered pairs, in other words, this represents -3 comma 1/8. So if I input my first value of -3 comma 1/8, 1/8 is a very small number, close to 0. So at -3, when x is -3, I have y very close to 0 at 1/8. When x is -2, I have y is 1/4, so a little bit bigger than a 1/8, but still close to 0. It would be 0.25, so maybe somewhere up here. And at -1, we have a half for y. And when x is 0, y is 1, so I have a point here. And when x is 1, y is 2. And when x is 2, y is 4. And when x is 3, y is 8. So you could see that if I continue going on to the left, it says, what do you notice happens to x as we approach -infinity on the left? So if I continue such as numbers as -4 for x or -5, we would just get increasingly smaller. For example, 2 to the -4 is the same as 1 over 16, which is actually half as small as 1/8. So I can't even draw it because my point would get touching the x-axis, but it would just get closer and closer to 0. And if I said 2 to the -5th, that would be 1 over 32. And 1 over 32 is even smaller than 1/16, so I would get even closer to 0, but I would never quite reach 0. For example, if you had 1 over a really large number, such as 100, that would just be 0.01. So it would be close to 0, but it wouldn't be 0. So as I go really far, infinitely far to the left, I will just approach 0, but never reach 0. So when we have a number that is approaching, when we have a line that is approaching a number, we call that an asymptote. So in this case, our asymptote would be the horizontal asymptote y equals 0. So you could see right here, the graph is approaching the line y equals 0. So this graph has a horizontal asymptote at y equals 0. And if I draw it, I'm just going to get a curve going through all these points as best as I can. I'm going to draw it. And then as I go to the right, I'm getting increasingly larger. Now, if you notice these points as you go down this list, I go from 1/8 to 1/4 to 1/2 to 1. If you notice, each time I'm getting twice as big. So 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8. So every time I go to the right, I am doubling. The next value, if you guess it, 2 to the 4th will be 16. And if you enter 2 to the 5th, it will be 32. So we call this an exponential growth because as I'm going to the right, I'm getting increasingly larger. So this is the characteristics of an exponential growth. Now let's look at the domain. If you look at the domain here, the input is the domain, and the x values, if you look at this list, I can go forever to the right and forever to the left. And there are no restrictions on any of the x values. So we say that the domain is all real numbers. So the domain will be all real numbers, but the range is going to be restricted because if you look at the graph will never be below 0 in this case. So we say that the range is y is greater than 0. And this is basically the characteristics of an exponential growth. An exponential growth has a value that it is always positive. So a is greater than 0, in other words, positive, and the base is going to always be greater than 1. So this is the characteristics of an exponential growth. The next video, I will talk about exponential decay.